Transmission Control Protocol, TCP, and Internet Protocol, IP, are the backbone of the Internet. Every time you send a photo, download a program, or even watch this video, your device doesn't send the data as one large file. Instead, it breaks it into dozens, hundreds, or even thousands of tiny pieces called data packets. This is where the Internet Protocol, IP, comes in. Think of each packet as a letter in the mail. IP places the sender's address and the destination address on every packet, then sends it across the internet. But IP doesn't care what happens afterward. A packet might arrive, get lost, or arrive out of order. That isn't its job. That's where its partner, Transmission Control Protocol, TCP, takes over. TCP numbers every packet and keeps track of them as they travel. If packets 1, 2, and 4 arrive but packet 3 is missing, TCP immediately requests packet 3 again before allowing the file to be reassembled. Once every packet has arrived, TCP puts them back together in the correct order, so the image, file, or web page appears exactly as it was sent. That's why TCP is used for downloading files, browsing websites, and sending emails, because in these situations, accuracy is more important than speed. User Datagram Protocol. If TCP is all about making sure every packet arrives, UDP takes a completely different approach. For UDP, timing is more important than perfection. When data is sent using UDP, it doesn't wait for confirmation, it doesn't check whether packets arrived, and it never retransmits lost packets. It simply keeps sending data as fast as possible. Why? Because some applications can't afford to wait. Imagine you're playing an online game, joining a video call, or watching a live stream. If a packet gets lost, it's better to skip it and move on to the next one than to pause everything while waiting for the missing packet to be sent again. That's why you may occasionally notice a brief audio glitch or a split-second blur in the video. The stream continues smoothly because UDP prioritizes speed over perfect accuracy. Hypertext Transfer Protocol, HTTP, and Hypertext Transfer Protocol Secure, HTTPS. Every time you open a website, a small conversation begins between your device and a web server. Your browser sends a request asking for the web page, and the server responds by sending back the site's files, HTML, images, CSS, and JavaScript, which your browser turns into the page you see on your screen. That's the job of HTTP. The problem is that traditional HTTP sends data without encryption. On an unsecured network, someone intercepting the connection could potentially read sensitive information, such as usernames or passwords. That's why HTTPS was created. It's simply HTTP with an extra layer of security provided by TLS encryption. Before your data leaves your device, it's encrypted, making it unreadable to anyone trying to intercept it during transmission. So whenever you see the padlock icon next to a website's address, it means your connection is encrypted and significantly more secure. File Transfer Protocol, FTP. Not everything we send over the internet is a web page. Sometimes we need to transfer large files between computers and remote servers, and that's exactly what FTP was designed for. FTP is widely used by web developers, system administrators, and data engineers to upload, download, and manage files on servers. One of FTP's key features is that it uses two separate connections at the same time. The first connection is dedicated to commands, such as creating folders, deleting files, or starting uploads. The second connection is used exclusively for transferring the actual data. By separating commands from file transfers, FTP makes managing and moving large files more organized and efficient. Simple Mail Transfer Protocol, SMTP. Every day, hundreds of billions of emails travel across the internet, and the protocol responsible for sending them is SMTP, or Simple Mail Transfer Protocol. When you click the Send button, SMTP takes your message and forwards it from one mail server to another until it reaches the recipient's mail server. But here's something many people don't realize. SMTP's job ends once the email has been delivered to the destination server. It cannot retrieve emails or display your inbox. When you open your email app and refresh your inbox, different protocols such as Internet Message Access Protocol, IMAP, or Post Office Protocol version 3, POP3, are responsible for downloading your messages from the server and displaying them on your device. In short, SMTP is responsible for sending emails, while IMAP and POP3 are responsible for receiving them.